The cumulative frequency distribution of volumes of petrol needed to fill the tank of 150 different vehicles is shown. For the class 20 to 30, determine the lower class boundaries. Now, if we take a look at the statement of the problem, it is kind of a giveaway, not the answer, but a giveaway to say that the values that we have here are quite likely not the values that they are looking for. Why? Because we have here a description of the class, and it is quite likely that if the boundary was included in the description of the class, then we wouldn't have any problem. This one would be too obvious to be true. Not only that, if we apply the correct knowledge, we know that the values that we have there are not the boundaries. And we'll take a look at how we will calculate those boundaries. We know what the problem requires, and we have chosen to extend the table to make some of the calculations easy. So we have extended the table, that is the extension of the table, in order that we can make the calculations easy. We are required to find a particular boundary, but the values that we have there are the limits. The values that we have there are limits, and some calculations require boundaries. Like this one, we are required to calculate boundaries because the statement of the problem requires that we identify a particular boundary. The values that we have are continuous data, but limits are not appropriate for continuous data, or they are not appropriate to depict continuous data, because the end of one class is not the beginning of another. So the values that are given in limits do not show continuity. And because they do not show continuity, then we will have to make calculations in order that continuity might be obvious and practical. So we see that what we have here, 20, one class ending at 20, the other one beginning at 21. They are not equal. We have one class ending at 30, the other beginning at 31. 30 is not equal to 31. So there is a depiction of discontinuity right there. And we need to depict continuity. Also, one class ends at 40, the other one begins at 41. And that is shown by the class limits. And because they are not equal, then we cannot use those limits to depict continuous data. Next, we will calculate the boundaries, and the boundaries will be the common points of consecutive classes. Boundaries are used in the construction of histograms and cumulative frequency curves that depict continuous data. So we will calculate the boundaries, and of course the boundaries are used to depict continuous data more appropriately than those limits. A boundary is the point where one class ends and the other begins. The upper class limit of the first class is 20, and the lower class limit of the second class is 21. So if one class ends at 20, the other begins at 21, the common point should really be halfway between them, and that just makes perfect sense. Common sense tells us that the boundary must meet those two values halfway, and will therefore be halfway between 20 and 21, which will cause it to be 20.5. However, mathematicians like to be definite and calculate them. Sometimes we have some values that you could just figure out based on common sense. But although common sense is applicable and would just make it perfect, then we cannot just use that alone. Maybe someone would reason for one particular value as opposed to another, and those two reasoning would be logical. They would make perfect sense, but we still need to have a systematic way of arriving at those values. So we will show how those values may be systematically arrived at. So what we have here is 20 plus 21, and we divide that by 2, which is, of course, the average of the upper class limit of the previous class and the lower class limit of the present class. And that should give us the values of our boundaries. Do not forget that for the depiction of continuous data, where one class ends should be where the next class begins. And in order to obtain that, we cause, for want of a better word or in a manner of speaking, those two classes to meet each other halfway. So the value that we have chosen is going to be the average of those two values, the upper class boundary of this class and the lower class boundary of the class following it. So there we have the two values going in. They should be equal. Where one class ends is where the other begins. And we find the average of those two also, and we no doubt will find the respective boundaries. As we see here, if we just use common sense, we would arrive at the same values. But for the intents and purposes of documentation and also accuracy, and so that we are not subjected to ambiguity when we are determining values like boundaries, then we have a systematic way of doing that. So if we do this continuously, then we'll end up with all of them. But we do not need to do that, because it just makes perfect sense. And what we will realize here is that we have sequences that we can complete in order that the other boundaries may be determined. The upper boundary of one class is always the lower boundary of the next class. The values in each column are in a sequence that increase by 10. The other values may therefore be determined. We are not just saying that it is increasing by 10, because if we go in the other direction, we are decreasing by 10 also. So these are increasing by 10, and we can therefore place the remaining values here. Of course, if we do this, we are also increasing by 10. But if we go in the opposite direction, we are decreasing by 10, and it's going to be very clear to us that the lower class boundary of the first class will be 10.5. So there are your other values. Now what do we need? We need, for the class 20 to 30, determine the lower class boundary. The lower class boundary. Notice what we have here. We have all of the lower class boundary values here. We have all of the values associated with the class 20 to 30. 20 to 30. So all of these values are associated with the class 20 to 30. And here we have all of the lower boundaries, and we can see where those two set of values intersect, and that will be no doubt the lower class boundary of the class 20 to 30. So there we have the exact value, which of course is the common value of the set of lower class boundaries and also the values in the class 20 to 30. And that value no doubt will be 20.5. And our question is answered. Let us take a second look at that. Now that we have calculated all of the necessary values, it is easy to just identify the lower class boundary of the class 20 to 30. So we have all of the values, all data values belonging to the class 20 to 30. We have highlighted them right there, as we previously did, and we are also highlighting all of the lower class boundaries. And we see right there the common value is the one that we need. So there we have the lower class boundaries identified also. And finally, the lower class boundary that we are seeking, which is the lower class boundary of the class 20 to 30, and that value will be 20.5 liters. As a matter of fact, the unit is given in this particular case. Teachers and instructors, get unlimited access to teaching aids for your virtual classrooms at richardjamesmathematicsresources.com. Also, this is the best place for the hearing impaired to master mathematics as long as you are literate.